We've talked a lot about DNS. We'll go take it a step further here. You've been a big proponent of DNSSEC, and but it's not quite there yet. I don't know if you know this, but we've got a little back and forth. I have sort of some reservations about DNSSEC, but by the same token, let's talk about it a little bit. Where do we need to go?
Look, if you didn't automate it, you didn't do it. Yeah. That's kind of how I like to say it. If we have a huge amount in security that is not automated. Look, you're a developer, and you want to send an email. I don't know. This is how I like to explain it. Why can't I email my doctor? Like, I mean, she's got an email address because she's in business, right? And in fact, I can email her. She just can't mail me back because it's illegal. Because we have a law called HIPAA that says if you can't communicate securely, you can't communicate at all.
Right, right.
And why is that? Like, why can't we write internet protocols that can just automatically send secure emails? We can send insecure ones. That works great.
Yeah.
You know what's going on? You want to go ahead and figure out where to send an email to. You look up a mail server in DNS, it gives you an answer, you send it there, you move on with your life. You want to go ahead and encrypt that mail, you want to get the key, the drama begins and it never stops.
So we really haven't managed the key management activity.
Things that can use DNS scale across organizational boundaries. There's a mail server, it's outside of my organization, I can find out where it is. There's a key server, it's outside of my organization, I have no clue how to talk to it. If I can't use DNS as a developer, I'm in a world of pain. And I see this world of pain when it comes to getting encryption keys. And so this is what DNSSEC ultimately does. It lets you get key material as easy as you get basic connectivity.
So it sounds like you're going beyond DNS per se. It's not necessarily just looking for domain names, but perhaps to use it for key material distribution.
The whole point of DNSSEC, the real point, is to get security as functional as connectivity.
Right.
Like, it's not a coincidence that our lack of DNS and security, like, it's not a coincidence that we have no DNS and security and we don't have security that scales. It's a consequence. That's why it's not scaling. You look at what the world would look like for IP connectivity if you didn't have DNS, and it looks exactly like the nightmare of key management.
Right.
And the nightmare of key management is very specifically that it is very difficult to automate. We have to get significant automation and security if we want any hope of solving a lot of our problems with the resources we have available. And where that's going to ultimately go is we're going to use the DNS as our cross-organizational key store. This is what's going to happen.
Yeah. So I agree with you thoroughly. We need to do something to improve the security on DNS. And I guess where my reservation comes in is completely separate from that point. I think it has more to do with the way we went about implementing security for DNS. That is, some of the fundamental issues that we deal with on DNS. We were talking a little bit earlier about reflective attacks and the opportunity for using UDP-based protocols in a nefarious way. It's really just any UDP protocol that has this problem.
Well, here's the thing. It's not like DNSSEC does anything special here.
Right.
Because it's not like our DNS reflection attacks are using DNSSEC as is. Like, they work just fine with normal DNS. Like, there are significant architectural improvements to be made to the internet to deal with reflective DDoS.
Yeah.
And they are totally orthogonal with what the actual data is.
Yeah.
It's like saying, oh, we can't use DNS because there's this record or that record. Who cares what records are? The point is the underlying IP layer. And our underlying ability to trace DDoS floods have a problem.
Yeah.
That's where we need to fix it.
So you're absolutely right. We have weaknesses in the the spoofing still exists. That's a fundamental problem. We have a problem in that we haven't got the ability to do tracebacks very well when spoofing does exist. And then, but the third aspect of it, I think, is just that legitimizing a connection. That is, why are we so fixated? And I'm just, why are we so fixated on UDP being the protocol for DNS? Is there a time when we should, if we suspect something, switch to TCP?
It's weird about what do we do about the fact that UDP-based protocols. So the problem is that UDP-based protocols, there's no evidence that the other side actually wants to talk to you.
Right.
We used to have a thing in IP called source quench, where the thing on a generic way could say, "Hey, stop talking to me." But that
And they might listen.
Yeah, it might. But that sort of stuff really got, we broke that part of IP. It was us. It was us in security who broke it. We did lots of things. We broke ping, and it's the only thing we broke.
Yeah.
So we have issues where, because there's no connection, people can go ahead and make huge amounts of queries and create huge amounts of traffic with no mechanisms for pushback. And the answer is to actually start investing in mechanisms for pushback, where we get automation throughout the traceback flow, throughout the shutdown flow, throughout firewalling. And it's doable, but we got to do it.
Yeah.
But protocol design is a mess right now. In the real world, it's like, hi, so the first thing you get to do is route everything over HTTP and probably HTTPS, because there's something in the middle that might mess with you.
Yeah.
Like, protocol design is sausage engineering in 2015. You really don't want to know.
Yeah. One of my slogans has been that on the internet, there are no rules, there are only guidelines.
Right.
And I think that's fundamentally what we have to sort of overcome, is we really need to kind of lay some groundwork on what are really good practices and have some means to enforce that. And I think that was sort of one of the topics that you kind of had here, is that, how are we going to fix this? What is there a way to really improve our situation from a security standpoint?
Cooperation gets a lot of flack because of the information sharing drama and who's going to get the information, who's going to be the great holder. But I really think that first off, I think we need more code and less position papers, documents, even standards. No, we need to actually start investing not just in writing actual software for people to use, but getting it out there.
Yeah.
I have a lot of friends in the financial space, and one of the quotes they told me is, we don't compete on security. Because if any of us get hit, we're all getting hit.
Right.
There's significant tooling that everybody needs to exist. And that in some ways, as us and professionals in information security, we're the only people actually directly exposed to the problem. We're the people in the muck to deal with all this stuff. The tools we build to start dealing with it, that stuff needs to be shared a lot more than I think it already is.
Yeah, sharing a lot more. In one respect, I think it may be just a fundamental information overload for your practical human being. That is, us as practitioners in security, we're paying attention to the security aspects. For the folks that are not practitioners in security, it's an overwhelming amount of information that needs to be comprehended in order to do a completely separate activity.
What do we do for them? There's one thing about building hard things that are hard. But there's another thing that's like building hard things so that the next guy, it's easy.
That's exactly, build the modularity so it's foolproof.
There was a great thing that was released a few years ago called Bang Exploitable. It's an extension to the Windows debugging tools. And what Bang Exploitable basically did was encapsulated all our knowledge when we look at a crash and turn it into, this is a security bug that you need to fix, versus this is probably not something you need to worry about. And it was great because it allowed a completely different set of skills to be able to address the problem. Right. There's a lot of people out there really who can see a crash, but have no idea, what do I do with the crash? I've got 100 crashes. Which are the ones that I need to go ahead and prioritize in the bug database because it's a problem? And Microsoft said, fine, here's a tool, type this, it'll tell you. And that is the path to follow. How do we find our problems and figure out what makes them easy to solve?
Right.
That can be open source that's out there. That can be even just releasing reviews and experiences of commercial products. It has to be the stuff that makes things better is widely known to make things better.
Analogy that just came to mind is I wanted to build a shed to store my junk on my property, and I am terrible with a hammer. My solution, bought a nail gun.
Oh, there you go.
It's a tool that made the job easy. It was only a couple $100. I love it. Just don't drive a nail in your own
But if you'd known that you could buy sheds down at Home Depot for around $70, you might have gone that route. But you didn't have the information yet.
I bought a kit.